In today's video, we're looking at nuclear fission, which is the splitting up of a large and unstable nuclei into smaller nuclei. At the same time, it releases loads of energy, which is how we get all of our nuclear energy here on Earth. Now, nuclear fission can occur in two different ways. Either spontaneously, where the fission is unforced and happens all by itself, or by absorbing a neutron, which can effectively split a nucleus by making it even less stable. In practice, spontaneous fission is rare, and so when we use fission in nuclear reactors, we have to use neutrons to get the process started. To understand how the process works, let's go through the steps. As we said, we start off with a large unstable nuclei, like uranium-235, and we fire a relatively slow-moving neutron at it. This addition of a neutron to the nucleus makes it even less stable, and causes it to split apart into two smaller nuclei, that we call daughter nuclei. It also releases 2 or 3 more neutrons, and importantly, loads of energy in the form of gamma radiation. Each of the neutrons can then go on to repeat the process all over again with another uranium nuclei. And so more daughter nuclei, energy, and neutrons will be released, which again allows the process to start over. Now, the key point to this process is that nuclear fission leads to a chain reaction, where the first fission can trigger more fission, which can in turn trigger even more fission, and so on. If this process isn't controlled properly, then the whole system can quickly get out of control and release huge amounts of energy, which is exactly what happens in a nuclear bomb. In nuclear reactors, though, the rate of fission has to be carefully controlled to stop it from getting out of control. This is mainly achieved by control rods, which can be lowered into the reactor to absorb neutrons, and so slow down the reaction. Meanwhile, the energy released from the process is used to heat up water and turn it into steam, which can then drive turbines that are connected to an electricity generator. The last thing we need to cover are the pros and cons of nuclear energy. The pros are that the uranium or plutonium fuel is relatively cheap, and it produces a large and steady amount of energy. And although it's not classed as a renewable energy, it is clean, as it doesn't produce greenhouse gases like fossil fuels do. On the downside though, nuclear power plants are very expensive to build, and the nuclear waste that they produce is expensive to get rid of, as it has to be buried under the ground in special bunkers. There's also always the risk of a major disaster if the plant malfunctions, which, although very unlikely, does make a lot of people suspicious of using nuclear energy. Anyway, that's everything for this video, so hope you found it useful, and we'll see you next time.